Hello, welcome in my quick update of a game I'm working for Dreamcast. In the meantime of working on Commodore 64 games, I wanted to take some break and do something with 3D. So this is the result of me playing with Dreamcast for 2 weeks. As you see, I implemented a few things for the simple game project. I don't know yet what it's going to be about, but I wanted to show you a few things. So one of the things is that I added textures, and this is of course a testing texture. I added some Lambertian light, and then you can see some fonts in the corner, so I can also display some text with some nice transparency. There is also a number of FPS, so frames per second shown. As you can see, this is not really optimized yet. I did some optimization, but this code still doesn't use stripping the triangles, which is a very nice feature of Dreamcast. So I'm going to work on that. But let me just show you what actually works. So you can see also some animations of this tree, which is really cool. And I'm just going to jump to Blender to show you how you can do stuff like this. I also did some optimization in Blender, but first of all, I will show you the first version of tree I did. Probably there are too many polygons still for this tree, but I will see. Anyways, I just have created tree which has a trunk and then has the 1 and 2 and the third like part of the crown, and then thanks to this separation I can animate these things separately, and this is really great thing. I use a sinus table for that. And then this one is really not very optimized version, so I will just run this with you just to show you how bad it is when I am using this first version of the tree. I just need to change a few things in the code. So yes, this tree, because this code actually detects what is the type of the object. I'm going to drop the other object, so that's why I didn't want really to leave it in the code yet. Okay, so now let's see. Okay, so this is the tree number 1. You see number of FPS was 47. Now with all the trees with 16,000 vertices, this is how many actually I'm pushing to the CPU, and FPS went down to 41. So remember this number of vertices, 16,000, and then moving back to the code, 16,000. I will just revert this and that. 16,000, and how much it was? It was, now it's 14, 13 even. 14, yeah, that's the end result. And you see that there are 47 FPS. So if I'm moving closer, you can see that the number of vertices is dropping. It's because I'm using the frustum cooling already, which is really great. So everything which is behind the camera or not in the view is just dropped from being drawn, which is why I'm getting now like 60 FPS per second. So this is really smooth, I have to say. I'm using the Lambertian light, so this is like a shading which helps me to also display some lightning shadow on the objects, so they can nicely look. And the object which you see in the front, the ship, is actually also having a little bit of a shadow, and there is a texture added to it. So I was playing a little bit with bumping, but I didn't actually manage to get it working well. So this is like a manual bumping I try to apply. So what it does is that there are not too many polygons, but you can do some tricks with things you want to be like a little bit deeper into the object without actually doing this geometry on the object. So just to trick the eye with a texture which contains some elements that are look like they are deeper a little bit, or they are more getting out of the object outside, like visually. So that's kind of a plan for the next iteration, I guess, to get these things done somehow. I tried baking and different things in Blender, but it didn't really look too good. So then I drop it just for now. I'm focusing only on this animation of trees, which actually looks fantastic. And as you see, the number of vertices dropped, but the trees are looking the same. Yeah, of course, it's because of a simple reason. There are some vertices that are really never visible, and one of them is at the bottom of this trunk. So what I did in this very first stage of optimizing is actually was actually to remove the face, because this one contains so many triangles that actually this really slows down drawing. Also, there is another one on the top, but yeah, I'm not going to change it too much, or I can actually. Also, I'm learning Blender shortcuts, so Shift H to hide everything else than selected, and then I can move with Tab to the edit mode, and then I can, with this icon, I can select faces, and then I can also remove this face. And then I think I needed also to actually make it higher a little bit. So then I remember that I used G and Z, I think, yes. And then I was able to actually move up, and then to scale it a little bit, you can use S, Z. Z is in the Z axis. So actually in this case, I need everything which is not Z. So Shift and Z, which allows me to change the X and Y, which is really cool. And this is how I actually saved so many vertices already. Probably I could also remove a few polygons. This doesn't need to be as detailed. I can save a little bit of this CPU power with just making the textures looking more rounded. So that's why I have this tree already in the another version. And talking about the sheep, that's the kind of the sheep I used for the other project I wanted to work on. And as you can see here, this is this kind of manual bump I wanted to do. It doesn't look really great, doesn't feel really great, like it's inside this polygon, because it's just the one flat polygon, but already gives some idea that this polygon drawing can be done with this nice trick. And you see the texture on the left side, so I can also draw all the textures really simply in the texture paint mode. So this is really cool because I can just adjust the texture, and then the image is already changed. And then also I did mirror of this object, so this helps me to actually save some data, because even if I'm drawing a texture on one side, it's copied to another symmetrically. So this is really cool. Then the next step would be probably to work on more movement animations, because this tree just moves a little bit up and down. But this is already a lot of fun, because with that engine I just created to learn how to work with 3D, I can simply apply already, as you can see, different animations. So it's all up to the code. Of course, this doesn't look good, but this is just to show you the potential of all of that things I'm working on. So this is really exciting at this stage. And I want to learn these bumps effects, how to apply them in a single texture, because that would be most efficient. And then also the other thing I was able to improve was to actually not using the PVR prim, as it's called, to draw meshes, but to draw everything directly by using store queues. So this is actually a very basic thing in Dreamcast world, but this is the code which actually does the same exactly the same as the other, as the queued version, but here I'm using PVR Prim, which just, it's much slower, it's 20% slower. I'm going to show you actually. And just this PVR Prim, it's slower, while using the PVR DR commit is much way faster. And in order to make it working, you just have to initiate DR state, which is actually just this PVR vertex, which I'm directly pointing to be used. So that's why the code is immediately sent to QStores. And this is the slower version, as I said. Now I have 33 FPS, but let me just move to back to show you all the meshes. This already gives me 33. So just for this, the time spent is 29 nanoseconds, and this is super slow. I am getting only this 60 FPS around when I have 6,000 vertices on the actual screen. So this works pretty well. The optimizations, I did a few other, but this was one of the easiest one, the simplest one. Then I look into a little bit more into the whole drawing of the meshes and things like that. And also, of course, the frustum cooling really helps. So I did also a margin, so that when there is a distance now for 50 float, then it will just start to remove the object. So I guess I will try to work on some fog in the future, so it looks nicely. It doesn't just cut these objects. Also, what I could do is something called LOD, which would exchange a mesh with a simple version of the mesh. So if the mesh is really far, then I can just, for example, I don't have to use so many polygons, so these trees might be even at this, I think at this distance, the one which are the furthest, they could be just simplified already, so then I don't have to draw as many vertices and still keep the frame really low. So there are many tricks I'm going to probably add to this engine as I go, but for now this is just the first version. I want to have something simple, so I'm going to continue with other items which I have on the list to add some textures to the trees for sure, some music, maybe do something with VMU, and then collisions, of course, the detection, and I will see what kind of game will be this. So thanks for watching this one. I'm going to continue and hopefully see you in the next one in the future. Have a nice time. Cheers.